Good morning, good afternoon, good evening, and welcome to the very special mini series that we are doing here with the Call for Code for Racial Justice team. I'm Chris Short, host for the most of Red Hat live streaming, and I am joined by some of my friends over at IBM to talk about the project TakeTwo. Demi, please introduce the topic of discussion today, please.
Yes, thank you so much. Thanks again for having us here again,
My
Chris.
pleasure.
Always a pleasure having or being here on your show. So today I have the TakeTwo team here with me as well, and we're going to get a little bit into what TakeTwo is pretty soon. But before we get started, I just want to give a quick intro to anyone who's not familiar with Call for Code for Racial Justice. If you've not been tuning into this OpenShift TV series, just want to give you just like an overview of what Call for Code for Racial Justice is and what Call for Code is. So Call for Code for Racial Justice is a component of Call for Code. We'll get into that shortly. Just our speakers who are going to be speaking today, Joanna, Naoki, Anna, and Nagma, who will be talking pretty soon, just after I give this intro on Call for Code. And we have a few additional team members here as well. So many people have been participating in this project from the beginning, and some of them are still currently working on it. And this list is continuing to grow. So if you see us in a few months, the list will be even longer than this. We have lots of people joining the community and participating. As you'll see, we also have a lot of different roles that are available for people to contribute to as part of TakeTwo as well. So getting back to Call for Code, Call for Code is essentially one of the world's largest tech for good initiative of its kind. So essentially we have a global challenge every year where developers and non-developers can come together and design projects that are solving specific social issues. So we've done a lot of different topics. So we've done natural disasters, climate change, COVID-19. And in 2020, we had a spot challenge for racial justice. And out of this spot challenge for racial justice emerged Call for Code for Racial Justice. And now we have 7 offerings that are related to this. So Call for Code for Racial Justice emerged in 2020. As you might know, there are a lot of things happening in the US specifically around race relations. And there was a bit of a social and racial reckoning in regards to the killings of specific unarmed Black citizens in the United States. So IBMers within who were interested in doing something about this issue, they came together and they decided to do a spot challenge around a Call for Code. So essentially they wanted to do something where they could feel like they were giving back and contributing to eliminating systemic racism. So out of that emerged these 3 pillars: police and judicial reform and accountability, diverse representation, and policy and legislation reform. So during that time, we were able to create solutions and create projects that aim to address each of these issues. And actually, funny enough, I had the pleasure of working with diverse representation at the time. I was supporting that pillar. So I worked with another product manager, Ian, who was leading TakeTwo at the time, and a few other projects. So, and we'll talk a little bit more about TakeTwo shortly, but these were the 3 main pillars that we had as part of Call for Code for Racial Justice. And just a timeline, like it's only been a little over a year at this point since the launch of Call for Code for Racial Justice. So it was launched last year in Juneteenth. In June of 2020 with a spot challenge. We had a lot of different participants who were involved, 500 volunteers globally. We had distinguished engineers, master inventors. As I mentioned, we created 7 open source solutions, and now we have a backlog of about 20 solution building blocks that can be used for creating other open source projects. And then we launched Call for Code for Racial Justice and externalized 5 of these solutions with the Linux Foundation. And we're able to externalize an additional 2 of them in this year. And we have a really wide variety of things within our tech stack. So if you're interested in Python, you're a front-end developer, back-end developer, there are different ways for you to get involved with our solutions here today. And today, as I mentioned before, we're talking about TakeTwo. So I'll let the team take it away to tell you a little bit more about their work.
Thanks, Demi. So I'll kick us off. So like Demi mentioned, when we were presented with the Call for Code for Racial Justice Challenge, the problem statement that our team wanted to focus on was that bias can be learned and perpetuated in different ways, through societal beliefs, misrepresentation, ignorance, And ultimately, this can lead to inequitable outcomes. And a lot of times what happens is that this is something that's unconscious, that people don't even realize that they are doing or perpetuating. And so we thought that this would be an interesting problem to tackle and look into deeper and see what we could do to help. So if you go to the next slide, Demi. So in particularly, we wanted to take a look at language, right? So I love this statement by our very own Dale Davis-Jones and Tim Humphrey from IBM, that words really, they shape our worldview, how we regard others, and how we make others feel. And so language is just such a powerful part of society, culture, everything that we do. And so we saw that there was this opportunity that we as a team could potentially address the issues that could be perpetuated via language, racially biased language, and mitigate it. And so after the murder of George Floyd, there was a lot of scrutiny that was being said in the media, how it was being said, why there was a racial bias persistent in it, and there's lots of educational opportunities. And people were just really sharing this wealth of knowledge and background as to where the stereotypes were kind of being perpetuated. And pointing out social media posts, news articles. And if you think about it, we're really all exposed to media, news, fake news on an hourly basis. And so it's inherent in everything that we read. And we want to be able to mitigate the perpetuation of these hurtful ideas and biases. And our team, we actually came together because we were often humbled by those who were sharing the background and the use of certain words and phrases. And we saw a need to even educate ourselves and bring awareness to question our own biases in any content that we've created or consumed. And so, all the headlines that you're seeing kind of highlight that other companies and organizations, that people were all kind of thinking about this. And so some of you may be aware of these movements that have been happening for the removal of racially biased or insensitive language from different products, services, et cetera. And so, we think it's just so powerful to understand the background and the words of the phrases that we choose to say, as well as continue to say. And so we really operated under the premise that awareness is key, and that we believe that bringing awareness to when language is racially biased and why would help mitigate content that is being created from people just not realizing or knowing that what they're saying consists of racial bias, and therefore it could minimize bias that's perpetuating via the content that they're creating, and then ultimately reduce the offensive and harmful content that's out there. So Demi, if you could.
Yeah, actually, I had a question for you here. So did you guys notice any, or have you seen any work that talks about maybe are there different strata of types of biases, like in terms of, for instance, like what someone says in social media versus a news publication, just in terms of the effect that it might have, or even the context or the construct of that? Or is there anything that you guys know about how that might differ from different, in different contexts, essentially?
So from at least what I think I noticed was that I felt like in social media, there was a lot of people emulating things that they thought were funny, just out of humor. And I think they thought it was lighthearted and it wasn't really offensive, but people were taking offense. Versus I think news articles were more so I don't even know if they recognized that the way that they were describing different populations was just different and harmful for people who are in the Black population versus how they were describing crime, for example. And so it felt like in social media that it was more coming from a humorous standpoint versus in the media, I don't know, for some reason, just the way that they were describing was not humorous, but just different. So, I don't know if anyone else has anything to say on that.
Maybe I'll comment briefly on that. So I think it would be an interesting thing, to consider in machine learning part of the solution, if it can take advantage of that sort of broad contextual information to boost the accuracy of bias detection. But maybe I'll say more about that later.
Okay, cool. Looking forward to your section. All right. So moving on.
Okay, so we initially began with the idea to build a tool that would detect bias in content, but we quickly realized that at the time, at least, there was no publicly available data set for us to leverage. And so, this kind of made sense. Language is incredibly subjective, and while it is more straightforward to identify some overt forms of racial bias, it's a lot harder to capture the more subtle forms. So kind of speaks to what we just talked about within like the different contexts, like social media versus like news articles, gaming chat rooms. And so, this is really where our Chrome extension, our browser extension came into play. We wanted to see if there could be a way to maybe crowdsource this data via trusted contributors. And so we wanted to, our goal was to really provide a trusted community of members with a tool to flag content that they were seeing consisted of racial bias and provide a mechanism for them to explain why something was racial bias, racially consisted of racial bias. And so this would feed into our machine learning model, which Naoki will go into further detail on. And ultimately, it would serve as the data to help our machine learning model classify when phrases or expressions within certain contexts may be racially biased. And ultimately, this would then feed into our API, which Johanna will go into a little bit more detail, that we wanted users to be able to leverage to check their content to see if it consists of racial bias, and therefore be able to feel empowered to know and then make a decision as to whether they wanted to continue using that language, or maybe there was a different way to get across the point that they were trying to make. And to be clear, we understand that this is an extremely complicated task that's dependent on context. We don't really know what the ground truth is here. But we do think that we have a great starting point, at least to explore these different concepts and ideas. And so that's kind of an overview of our solution.
Nice.
Very cool.
And so,
question.
Yeah.
You said you had a Chrome extension with trusted people using it. How did you make that happen? Right? Like,
yes.
Are you going to get into that? If I'm asking too early, just tell me.
No, I can definitely, or others, please jump in. But so something that we came across was we wanted to balance giving power to the community to flag content while also recognizing that there are bad actors, and that we need to make sure that there are credible people marking this, and that people have the correct, or the background to be able to understand when something is racially biased. And so that's the reason why we're calling out trusted contributors. And so we are still kind of in the process of identifying what that looks like or who that is. And our small team of original challenge, when we were just started off, it was a challenge that we're not sure if we're even the people to make that determination. We kind of want to talk to experts to help facilitate that and understand what that looks like. But that's just a little bit of background on that.
Awesome. Thank you.
Sure. So I will pass it over now to Johanna to talk a little bit about our solution architecture.
Thanks, Nagma. So hopefully everyone can hear me.
Yes.
So my name's Jo, and I worked as a developer on this really fun project. So the solution at the moment, and it's definitely not the final solution, but it's basically built up of 3 components, and our repos are split into 3 to match the components that go along with this architecture. So as Nagma mentioned, one of the issues we found at the beginning was not having a data set that contained that more subtle form of racial bias. So it's very easy to find toxic language data sets or racial slur data sets. They do exist, and we can bring those into our solution. And we have used those to sort of for training and things like that, for training our models. What we found more difficult to find was things like when Naguma was talking about news articles that might be more heavily making it look like young Black males are more heavily engaged in crime than the rest of the population. That's more difficult to identify, and there's not that many data sets that kind of contain that information. So we decided, okay, let's create something so that someone could privately, if they're browsing, because people were already doing it on Instagram, on Twitter, they were already picking out a piece of content from someone's website or from the news and saying, hey, you know, this is not okay, and this is why. So we thought if we could give them the mechanism where they can actually do that via a private tool, so it's not something that anyone else can see, it's just privately highlighted. They go into their browser, they can be on any web page they want, they highlight the word or a whole sentence or paragraph, whatever it is, and that data is then via the API posted into a database, a backend database. Now, in our GitHub kind of get up and running example, that database is a CouchDB instance.
Nice.
The overall plan for the project long term is for the community to own the data set via some sort of organization who are kind of impartial. So we obviously someone who's kind of neutral ground for something like say, you know, to kind of, because it would basically be like, this is the definition of racial bias. Some people might interpret it that way, so it needs to be kind of owned by the community. The API then calls out also to the machine learning model. So basically at the moment we have just a very simple text editor, which we'd also like to turn into a Chrome extension. At the moment, what happens is on the client side, they can actually type content. So if they're thinking of writing an article or posting something to social media, they can type what they want in the text editor. It makes a call out to our machine learning model, which then will highlight any parts of that text or sentence that it feels might contain, well, it doesn't feel, that it finds might contain racial bias. It's not that clever yet. And then it will actually explain why it thinks that it's a very clever machine learning model, why it's suggesting that you might want to reword. We've also talked about offering alternative words to things that people are using. And this could be anything from social media posts all the way to code that someone's creating online. So I'll just share my screen and then I'll show very quickly how it works. Hopefully it hasn't logged me out. So just to recap, we've got 3 GitHub repos. This is the repo for the API. And in here, you'll find everything, the information about what we collect from the Chrome extension. So the categories that we define. So I'll go into that when I show it. And then a getting started guide. Nice. On how to get up and running. Today it is not running on OpenShift, but we have run it on OpenShift when we were building the solution as part of the call for code. This is just running on my normal machine, but you can run it in a cloud native environment. We've got the so this is the web API. We've also got the data science repo. And then we've got a repo for the Chrome extension. So the way it works is we've got this API running when you get the solution up and running, and there's a number of different endpoints and they're used for various things, and that's all explained in the docs. But basically, you can get the marks that are in the database. You can post to the database, which is what happens when, if you post a mark, that's what happens when someone selects some text in the Chrome extension. What I'll do is I'll just show the Chrome extension. So in order to be impartial at this moment, I've just got an article about lettuce. because I don't want to say what I think is racially biased or not. But basically, the user can toggle on the cursor once they're logged in. And this will allow them to choose any words or phrases. So if I thought addition was a racially biased term, oh, I've done that wrong. Let's get rid of that. So it's a bit slow. Let me just reload it because it's gone a bit slow.
I'm sure you streaming video has nothing to do with
Yeah.
that.
Okay, let's just pick another one. It's hopefully I can okay, and then the user, once they've highlighted, they'll be presented with 6 categories, which is our initial idea was to have a category of racial bias. We've also discussed just having a kind of Boolean, so yes or no, it does or it doesn't. We're still kind of, I'd say, figuring this one out, but essentially the user can select. They can also, again, it might just be really slow, but they can also change a category if they want. So if I had selected stereotyping, I can change it. I can also delete a mark, which will call, basically, and it calls all those endpoints that I showed earlier in the API. What then happens is, so that's basically the Chrome extension, and you can see that it needs some UI design work because it's extremely basic. And actually, what was quite cool about this is we used an already existing just general highlighter tool that existed for browsers. And we just took the, it was just like a highlighter tool that highlights stuff in yellow pen. And we used that open source project and then kind of made it our own in order to suit this project, which was a really nice way of using something that's already out there in the open source world and kind of modifying it to our own kind of needs.
Sorry, so before you leave that page, I was just curious, just a little bit more about the Chrome extension. So I guess it's kind of disappeared, but it had something about copying. What happens when you do that? Copy all, yeah, I guess remove all. What is copy all?
Yeah, so I think copy all will take all the text that you've highlighted, and you can probably paste it somewhere else, like in a text editor if you wanted to, something like that. And removal will just remove all of your marks that you've made.
Okay.
There's lots of work to do on this Chrome extension. So I think that there's a lot. If you look in the Chrome extension repo, you'll find a whole host of issues that some of us have raised that need to be worked on.
Nice. So I was curious here, is it like for centuries in human, the highlights, does it tell you what the racial bias is or just tells you that's highlighted?
So at the moment, it just tells you what's highlighted. Obviously, because this is the side where people are capturing that data, so it wouldn't know what the racial bias is yet. We want to add like a space where they can not only highlight, but then fill in some information about why they've highlighted it. And that information could then be used by the machine learning model as well. That's all stuff that we kind of haven't got around to.
Okay.
But it's a good idea. So on the other side of the kind of API is our text editor. And for now, I don't have it hooked up to a machine learning model. I just have it hooked up straight to the database that I'm using. But the general idea is I type in a sentence in the text editor, and it makes a call out to the machine learning model. And it would say, you've got this word, and we found out that we think it's a racial slur. And here's a definition of what that is, and here's any additional information, which might be things like you could use this word instead. And that is pretty much it. I've obviously got my database running in the background, but this is sort of not that interesting because, like I said, we really want this to be a community-owned data set and not something that one person just spins up on their own. There could be scenarios where companies want to use their own data for a specific reason. So I know at IBM, they have a set list of words that they would like, that people should not use. We have done a project within IBM where before they post content onto their IBM developer website, they used our tool to scan the content of the kind of article, flag any words that were not appropriate to use, and then sent a message back to the developer who wrote it to say you need to maybe reread the content and maybe change some of these things. So we have deployed it within IBM on like a trial project.
That's
and
nice.
yeah, that's about it. I don't know if there's anything else. I think there's one more slide that I probably need to talk to you before Naoki, which is about data authentication. So obviously Naoki will go into data authentication from a machine learning perspective, but there's some things that we've identified that we would potentially do to mitigate malicious actors or unreliable data. One thing I forgot to say is that the data is the user is obviously authenticated before they use the Chrome extension. That is set up using one of the IBM App ID service. Initially, we had the idea that we would ideally want anyone to be able to contribute, but I think the way it's moving now, I think it's probably was the wrong choice. However, there could still be bad actors, even if you've gone through a very rigorous process. So, and also we want to kind of build up some consensus around the data that we get. So we haven't implemented this yet, but these are kind of some mock-ups of the kind of thing we want to do. And this is very typical of something like what Google Translate does, just asking the user while they're highlighting text, serving them a pop-up to say, click on the words that you feel like are racial slurs, so that maybe this data is already in the database, but we just want to verify it and try and build up that credibility. Same for maybe serving them a sentence and saying, which category of these do you feel is most appropriate, just so we can kind of build that verification into the process. And we still need help with that, like many things in UI, in the UI space. So I will now hand over to Naoki, who will talk more about machine learning.
Awesome.
Okay, thanks, Joe. Demi, if you can go to the next slide, please. Yeah, so this is sort of a one-slide depiction of our roadmap, if you will, or kind of vision, cautiously optimistic vision of where we want to go in the machine learning component. So there's essentially a list of different versions of machine learning component with increasing sophistication, I guess. And starting from the left, version 0 would be sort of a normal machine learning version where you do database or dictionary lookup. Version 1 is a classical machine learning version where you can train a classifier that can detect what sort of expressions or maybe even long expressions in sentences and paragraphs are biased or not from labeled data. Version 2 is the more next sophistication of that, where you leverage the cutting edge deep learning technology to do this in sequential context. And the version 1 has been implemented in the repo, and there's ongoing work on version 2. But the rest of the versions actually are not implemented yet. It's in the future tense. Version 3, we call the AIX, or the explainable AI model, is a variation of the previous 2, where it not only it can flag a whole paragraph or whatever as bias, it can also point to specific words or expressions within it that are responsible for that bias or not judgment. Version 4 is one that tries to address the markers credibility question that Joe was talking about, another mechanism to address, where we try to learn the credibility of the markers in a crowdsourcing context and use that information to build better and better machine learning models. Version 5 is an extension of that, where you use that credibility information to actually actively choose and seek label data from the markers that are more credible, and about the questions that the models really want to know about. So that's just sort of the summary. And in the next couple of charts, I will go into a little more detail about two of these versions, version 1 and version 4. Next slide, please.
Yeah, so just a question here before we move on. Can you explain just for the general audience what is meant by broad context versus sequential context?
Yeah, so well, maybe I shouldn't say broad, but in context. So in Joe's demo, she happened to be picking words to label, but in general, you could just label a whole context like a paragraph. So this is trying to basically the version 1 is going to classify whole paragraphs or whatever into biased versus non-biased. And sequential means it really is paying detailed attention to the sequential context of in a sentence structure, and that's something that you need deep learning technology for.
Okay. Pardon my understanding or lack thereof of machine learning in general. Like, how hard is it to train these models, right? Like, this has to be a very challenging model to train, I feel like.
Yeah, good question. I think maybe I will say more about what we have done concretely, and I think it will come out. It's not done by any means done or complete. We have a lot more to do. So this one is the first version that we have implemented, and it's using relatively classic machine learning classification technologies like support vector machine and naive-Bayes classifier, combined with what we call bag of words representation of text. So the picture on the right is sort of illustrating how this works. Sentences coming as data, and they're labeled. In this case, they're, for simplicity, biased or unbiased. And then these sentences or longer are transformed into a representation called a bag of words, which is essentially a vector of frequencies of many, many words. So these sentences are mapped into a very high dimensional numerical vector space, like, not necessarily zeros and ones, but often zeros and ones. And then you can run classic machine learning classifiers like support vector machine and naive-Bayes classifier to come up with a classification boundary. And this you do on a bunch of training data, labeled training data. And once you have that classifier or the model, you can apply it on a new sentence or paragraph. In this example, it's a master replica, which is also transformed to a bag of words, and then the classifier is applied to that, and it comes up with a judgment of biased or unbiased. So that's how it works, and it's being implemented using scikit-learn library, and that you can find it in our report. So that's our first version. If there's a question, I'd like to move to the next one. If you can go to the next slide.
There's one question in chat. Could this solution be used for other languages, or is that something that's in the roadmap?
That's a good point. One of the advantages of machine learning based natural language type methods is that you train it with data. So if you train it with English, it will learn about English. If you train it with German, it will learn about German, and Chinese, Japanese, whatever. So.
And one thing to note, I think our solution right now is primarily English, but also US. I think we've been kind of US centric, and so that's definitely something that we've been trying to consider moving forward, considering different cultures, different languages, and all of that. So
awesome.
Yeah. There's a lot more that you should and you can do about them. It doesn't all come automatically, but it's basically extendable. That's the
awesome.
Yeah. So this version 4 that we call Ensemble consensus learning, this is our vision or an attempt to address the issue of there being unreliable markers or even adversarial markers in crowdsourcing context. For the reasons that Joe stated, we believe that crowdsourcing is very important, and that's the way to go. But it's also challenging if you're collecting data from thousands of anonymous or people from all over. You may not necessarily have all reliable people, but how can you try to detect that and learn from or leverage that information? So here's an idea. We leverage a general idea called ensemble learning. That's a notion where you have a number, potentially many machine learning models or methods, and basically you make a judgment using the ensemble. That means, as shown in the equation on the top, basically doing averaging. So you do like a weighted voting by all of the machine learners in your ensemble and make a sort of an average judgment. So that's one thing about ensemble. The other thing about ensemble learning is that you can also learn the credibility of those models by updating their weights, credibility weights. And you do that by this second equation, where basically it's cutting the weight of a model that makes a mistake. So every time it makes a mistake compared to the ground truth label, it cuts, for example, it cuts the weight by half. So it actually, you can show that it quickly learns and zooms into the good set of models. So this is the general idea of ensemble learning. But we apply this in our context, and there are a couple of things that we need to do. The first is that for those models, we don't really want to have just the markers. If you have 1,000 markers and train a model for each marker, you don't have enough data from a single marker to create a good model. So we instead create many models, but you train each one with data from a subset, arbitrary subset of the markers. So that's sort of how it's depicted in the picture. And then you feed random subset of all of the markers into different models. You could have hundreds of models corresponding into different subsets. So that's one way that differs from the general ensemble learning. The other difference is that we don't really know the ground truth for the very reason that some of the markers are actually unreliable. So how do we know when to learn that one of the models made a mistake? So that's where we use the consensus, meaning the weighted average prediction of the current ensemble you treat as if it was the ground truth, and then you penalize those models that deviate from that. So that's why we call it ensemble consensus learning. Now, so with some assumptions about the reasonableness of the ensemble, you can hope to show that this also will quickly converge and will quickly zoom into those models that are built with credible subsets of credible markers. Anyway, so this is an idea that we would like to take forward, but it's sort of abstract. So if you can go to the next slide, in the next couple of slides, I would like to show some concrete work that we have done. Much of this was done by Pritika, who couldn't be presenting with us today. But what we did was, rather than sort of doing all this in abstract, we wanted to do it in concretely. So we found this data set called the Jigsaw data set from the Kaggle competition. It's a decent data set about racial biased expressions. The data set has 1.8 million observations, but it's not just about race or it's not just about Black or Asian, as it's shown in the histogram on the left. There are many different kinds of biases that are present in the data. But by and large, building machine learning models to learn these biases, that's a similar kind of modeling exercise, irrespective of the exact type of bias we're talking about. So this is a very useful data set. Another interesting thing is if you look at, so there is a column in the data which stands for severely toxic or not. And for now, we're using that as the target to predict. So we're trying to judge whether something's toxic or not. Interestingly, the sentences in the data, if you look at the presence of obviously offensive terms like the F word or the N word, you can see this monotonic increase in toxicity as a function of the frequency of those terms. But if you look at some more new words, like pig or dog, it's not that simple. So there's a lot more that you need to do to learn rather than just sort of counting the frequencies of these words. If you can go to the next slide. This slide is summarizing the results we have obtained thus far with this data, with the first version that I talked about, the support vector machine version. There's a bit of an extension that we did called TF-IDF. It's kind of variation of the bag of words. I'm not going to go into detail on that one, but so far we've obtained the accuracy figure around 80%. It's not satisfactory. So this sort of in part answers your question, Chris, that it is a challenging problem, and we do need to leverage more sophisticated and cutting edge methods to improve. But it's not a bad start. This
is awesome.
Yeah, and there's some this sort of spells out the steps of this involved in this modeling, like cleaning up the text or removing stop words, dealing with imbalanced data by downsampling the non-toxic data and upsampling or the toxic ones, and so forth. And we used SGD, a method for training support vector machine models, and we're using a specific version with parameters with that. If you can go to the next slide. There's some takeaway from this exercise. We've done both support vector machine and naive Bayes. And as you can see, naive Bayes is getting about 75% accuracy. So even with this kind of classical machine learning technologies, some are better than others. And you can hope to keep improving. And deep learning, for example, I think will improve significantly. One of the indications that the model, as of now, is still not satisfactory is the fact that it's a little bit technical, but the optimal loss function of the model is something called the modified Huber loss, which means that there are outliers in the data, which means also that with the information present in the data in the sentences, it's not enough to be making reasonable classification for some of those ones. And so we expect that, maybe it's a sequential context, or maybe it's some other kind of contextual information that's lacking in the data that you would need to be able to make better judgment on those. So those are some takeaway lessons. Another comment is that this data comes with, as I mentioned, these different kinds of discrimination, like against Asian or against Black, whatever. We're not necessarily trying to predict those categories, but they could be useful as features because the type of offensive expressions might depend on those categories, and it could be helpful in refining the models. Another thing is that this data comes with the marker ID column, so you do know which sentences or which examples come from a particular marker, even though we don't know their identities. So we could actually try to do this version 4, the Ensemble consensus learning, where you're trying to learn the credibility of the markers. That's something we haven't done, but this data set actually is rich enough for us to do something like that. But eventually we want to move to crowdsourcing, where you can choose to collect more information, maybe demographic and other kinds of contextual information about the markers and so forth, and also do selective, sampling or the active learning. That's not really possible with the existing data set. So we are, anxious to move to the crowdsourcing mode. Sorry, I ran on kind of long, but
Oh, you're fine.
this is it for the machine learning component. Are there any other questions?
Yeah, I had some questions. Can you talk a little bit just about the computations required for this, especially if you're moving to deep learning? So how easy is it for someone to do this locally on their computer? Or what have you guys thought about that?
Yeah, so the classic machine learning models that we've done, I mean, that it's easy to do like on my laptop, and training takes maybe, seconds. So that's not a problem. But deep learning, if you really, I think maybe at this level, it wasn't that bad. I would have to check with Ritika. She probably did it on her own laptop. But as this data size increases, and you want to train, for a longer period of time and so forth, you may want to leverage GPUs and going to high, more capable setup. But I think we could also do that with cloud clusters, right?
Okay.
It doesn't have to be IBM Cloud, but IBM Cloud would provide such capabilities, and you can seamlessly train these models with no particular difficulty problem.
Nice. And what's the volume of data that you think you might need in terms of crowdsourcing? So like just a call to action to the community. How much more data do you guys think you need for your next phase?
I don't know. It's difficult to say how much. I mean, this data set has 1.8 million, which is a decent amount, but it doesn't. It's not restricted to the type of racial bias that we're interested in. So that's a lot less. But with crowdsourcing, we have the ability to select the markers and select the data that we want. So that would reduce the amount of data that we need. But generally, I mean, hundreds of thousands would be.
Okay. Okay. Good to know.
I actually have a question.
Okay.
So I know we've talked about context and where we're kind of flagging, and I know in our solution we've talked about like including where the data is coming from or like what platform we're on. Did you see that was a field in the Kaggle data set?
That's a good question. I doubt it. I haven't checked thoroughly, but I'm doubting it. Yes, that's an example of the type of additional information we would like to collect.
Yeah.
In the crowdsourcing setup.
And sorry, maybe I can jump in there as well. Obviously we've built in to capture where data comes from, but I think to Demi's point about how much data do we need, I don't know what Naoki's thoughts are, but even when we've collected enough to train an initial machine learning model, I think racial bias is something that what is racially biased changes over time. Mm-hmm. So it's something that we'd want to keep updating and keep iteratively improving over time. Also, so that we can understand how the definition of racial bias might have changed over time, depending on political events, different types of situations that unfold. So I think it's something that we need an initial set of data, but we want to keep that process going and improving and things like that.
Yeah, that's important that our models are dynamic and able to adapt to changes in society also.
Exactly.
Okay, maybe we should move on to the next segment. Anna, I guess.
Hi, yes. So here are some of the immediate applications of TakeTwo that we're working towards. Text-based content like social media platforms, blogs, but there's also future applications that we would like to have TakeTwo be a part of, such as in the gaming industry and of course in other languages. And we're also actively working with different partners to realize and co-create a vision to grow TakeTwo even further. Next slide, Demi. So here I would just like to highlight where we are headed. We have kicked off our community meetings, and these are some of the things we're focusing on right now. Finding a home for our data, updating the UI UX of API and browser extension, as well as the training ML models. Next slide. And so here's where we need your help. As you saw, we have set up the foundation for Take-Two, but even with the current functionality, along with the great team of contributors that continues to grow, we're still looking for people that can help. This is a complex project, a complex problem we're seeking to solve, and excuse me, a complex problem we're seeking to solve. And so any contributions we can get would be really appreciated. We want to make it as impactful as it can be. So we are looking for varied skill set. And there's many ways to contribute. We're looking for data hosting, data scientists, designers, a full range. So if you are interested, or if you know of anyone else who may be interested, please check out the links that were provided in the chat, as well as listed on the next slide, Demi. And the links tell you how to get started, where you can find all of our repositories, and all the information you need to contribute. Thanks. Demi, go ahead to discuss the next. Yeah.
So
if I could, sorry, could I just pause?
Sure.
And yeah, I just wanted to say that, Anna listed off a bunch of the different kinds of help that we need, and just wanted to call out that while we talked a lot about like the technicalities of our solution, but I think we also wanted to call out that because it's a socio-technical solution, we really also need people who are experts in like linguistics and political science and media and all of that. So I think really no matter who you are and what background you have, what skills you have a very valuable contribution to make to our project. Technical, social, whatever it is. I think we're really kind of looking for all kinds of people in a broad, diverse community to help out. So I think that's kind of beautiful and also awesome about Take-Two. And so just wanted to call that out.
No, that's great.
That's very awesome.
Yeah.
Yes.
So yeah, just in relation to that, we do have some opportunities for you to get involved. As I'll put in this next few slides, you can join our Slack community. You can also join us for Hacktoberfest. So we're joining Hacktoberfest, which is a month-long celebration of open source contributions in October, from October 1st through the 31st. And we'll be participating with Call for Code for Racial Justice. All of our projects will be participating, including Take-Two, during this celebration. So we'll be having a kickoff event on October 6th at 5 p.m. Eastern. You can watch it. You can register for the event at ibm.biz/hacktobercc. That is case sensitive, or you can watch the replay if you're not able to catch it live. There, it'll be on the that same link. So, and for here, you'll be able to find out more about how you can contribute to our projects, exactly how to get involved in Hacktoberfest, and just learn a lot more, whether you're technical or non-technical, about ways you can contribute to all of our projects going forward. And just as a last call to action here, we'd like for you to join our community. There's definitely a lot of work to be done with Take-Two. So we'd like for you to join us. And if you would like to be a part of a community, you can do so by joining us through our registration page, which is ibm.biz/OSTV0928, which is today's date when we're filming this. And with that, you'll be able to join us on the Call for Code Slack channel. And once you get there, there are like going to be a million Slack channels. So the thing it's important to know is that you should want to join the Racial Justice Take-Two channel, as well as the Racial Justice General channel as well. And with that, thank you for joining us today. It's been really awesome being here and talking to you guys about Take-Two.
Yes, this is awesome. Thank you so much for the work you're doing. Thank you so much for bringing this project to the channel, and thank you so much for sharing your work with us. It's very much needed work, and I'm passionate about it. So thank you very much for doing it. Any other points you want to make? Just thoughts before we get off the air here, other than all the stuff I dropped in chat and links and such.
I think just thank you again for having us and letting us share our story, and we're looking forward. Hopefully people can join us in our project and the journey, and wherever we're headed. And so yeah, thank you.
Awesome. Thank you.
It's a growing community, and it's really nice to see this effort going. So we welcome everyone to join forces with us.
Awesome.
Yeah, it's cool to see when we all started like as a challenge to where it's gone and where we're sort of headed. So back last June to where we're at right now. is really awesome.
It's quite an achievement in just a little over a year. I mean, it's very impressive work.
Thank you.
So
Thank you.
awesome. So thank you all for joining. Thank you, audience, for watching, and stay safe out there, folks, and we'll see you soon.
Bye-bye.
Bye, everyone.